Roland Collins. Yeah. Let's welcome Roland from Intelibuild.
Good afternoon, or good evening. I don't know any Cantonese, so this presentation will be in English. I think the following presentations will be in Cantonese. This evening I'm going to show you how we're using BIM on the Cathay Pacific Cargo Terminal. For those of you familiar with the airport platform, the airport is in the background. Get a mouse to work here, we go. The airport building is in the background. This is Hacto on the right hand side, and this is the Asia Air Freight Terminals on the left. And the existing site will be converted, or the cargo terminal will be built on that site. So the presentation is basically in 5 parts. I'm going to give you an overview of the terminal. It's a very complicated building, so I'm not going to try and teach you how an air cargo terminal operates, just to show you the principles. I'm then going to show you how we're using Revit and AutoCAD MEP to actually do the design, the coordination, and the drawing production. I'm going to show you how we're doing the clash analysis and coordination, and then I'm going to quickly explain the drawing production. And then if I have a little bit of time at the end, I'll give you a demonstration of the actual 3D model so you can see the complexity of the model. So the project's being run by Cathay Pacific Cargo. They specified BIM nearly 2 years ago as the method by which they wanted the design team to coordinate the building design. So it's a client initiative. The design team is made up of Meinhardt engineers, civil, structural and MEP, and IDIS architects. WT partnership are trying to keep us honest and count the pennies, and Intelibuild is the BIM consultant. So what is an air cargo terminal and why is this the biggest in the world? The building has a site of about 110,000 square meters. The constructed floor area is nearly 250,000 square meters. It's about the equivalent of ICC that's being built behind us right now, this 4th tallest building in the world. It's an 8-story building. Some of the floors are 11.5 meters floor to floor. And the whole purpose is to service the air cargo industry. Hong Kong is the #1 hub for air cargo in the world. Most busiest air cargo terminal anywhere in the world. And why is this the biggest? It's measured by tonnage per square meter. So the aim for this facility is to process 2.4 million tons of cargo per year. Now, this is the picture of a silver bullet, as they call it. It's a converted 747 freighter. A freight aircraft can carry 110 tons of cargo, and a passenger aircraft generally carries 20-25 tons of cargo per passenger flight. When this facility is operating at its full, it will be dealing with more than 60 flights per day. So it's going to be a very, very busy facility. Cargo terminals have got lots and lots of acronyms, and I just want to explain one very quickly. When we talk about the levels of the building, we're referring to Cargo Terminal 1 as a level, Cargo Terminal 3, etc., etc. You can see here the general levels. There's a ground floor, which is the interchange between the airport and airside, the land side. There's the cargo working areas and the storage areas. I'm not going to show you all the detailed plans, but all of the drawings have been produced from the 3D models. So any drawing that's been produced on the project has been sourced from the Revit or AutoCAD MEP files. The ground floor is the interface between the plane and the cargo system. So basically, all of the trolleys will arrive at the ground floor, and they will interface directly with the machinery for the material handling system. So to make it more interesting, these are all in 3D. This is the same level. So the yellow is basically the interface where the airport operators interface with the system. The blue is a material handling system. It's a very complicated automated system. So it's made up of what they call roller decks. So the container that goes on the airplane is about the same size as an MPV car, and they weigh about 6 tons. So each individual unit is very large and very heavy. So these roller decks can move them around. You'll see in the next image the extent of some of these roller decks. This is a sorting area. So the roller decks will move through hoists the cargo up, and then it will get sorted around in the building. It will move from the airside interface, which is the ground floor, to truck docks up through the building. So there are truck docks all the way up to the building at different levels. This is the main processing area. So the cargo comes in a very large pallet. It's broken down into smaller boxes. So the main pallets can be stored in the centre of the building. So they have a cargo handling. Oh, this is very interesting. That wasn't put in the BIM model, I can guarantee you. I'm just going to wait for the noise to die down. Now we can see the rain more clearly, it's fantastic. Actually, I've got a very good view of ICC from here. Okay, so what we've got is you've got the cargo handling system in the center of the building. These are the working areas. The only place that's occupied in the building by personnel is these working areas here. So the majority of this building is not air conditioned. This building is generally ventilated, but not air conditioned. So there is local air conditioning only for these working areas. Because this whole restaurant's moving all of a sudden. I'll keep going. And then once you get to the roof level, you've got the very large storage area for the boxes, a large storage area for the containers, the storage for the empty containers of the roof, and additional truck parking. So in section, very, very simply, you've got the ground floor interface, the cargo storage, and then the working areas. So that's a very quick overview of the cargo terminal. Now I want to explain to you how we're going about the design. For those of you familiar with BIM, you'll understand the concept of a central 3D model. For those of you new to BIM, what we have is we have 4 different teams. We have a team working on the material handling system specifically. So we have Siemens from Germany making all of their models in 3D CAD. So the supplier has complied with the BIM standards and everything is being provided in 3D. The Meinhardt structural team are working in 3D. The IDIS architectural team are all working in 3D, and the building services team from Meinhardt are also all working in 3D. We have a team all based at Dragon House at the airport, and we have 25 people either designing or modelling this building in 3D. So there's one dedicated design office in Dragon House, and this is the outcome of the work thus far. The software we're using is all Autodesk products. So we're using Revit Structure for the structural model, Revit Architecture for the architecture. We're using Autodesk MEP. The new version of Revit MEP is quite good, but this project has been going for 18 months and we have decided to stay with Autodesk MEP rather than converting to Revit. These are some screenshots from the software. And then we use this technology called Navisworks for all the coordination. So Navisworks takes all these different drawing formats and puts them into a single model. So anybody who's familiar with cargo will recognize these images. To most of us, they're just industrial. So the cargo system that Siemens are designing includes vehicles that move through the building, hoists to move pallets vertically through the building, transfer vehicles, these roller decks, the interface to the airport, and the interface to the trucks. Inside the building there are a number of hoists, a number of cranes, lots and lots of steel structures, and lots of moving equipment. So all of that's been modelled in 3D CAD. So Siemens have put together a very, very detailed model and it's broken down in a very particular way. So we have the units for the actual cargo. So we have a space in the model where all the cargo units will move through the building. We have all the equipment that's required for that, all the roller decks. We have all the moving vehicles. And then we have, most importantly, all the requirements by Siemens for the pits. So all the structural requirements, all the openings, all the set downs, all the slab level changes are all modelled in 3D. This is a screen capture from the Revit architectural model. So here you can see the overall architectural model. If I break it down, these are the architectural floors.